Hello everyone. It's my pleasure to welcome you all to today's webinar on blockchain in aviation and logistics presented by Air France Industries KLM Engineering and Maintenance, Microsoft and Ramco Systems. I'm Cynthia and I will be your host for this webinar. Before we start the session, let me run through a few items of housekeeping. You would have noticed that your phone lines would be on mute. However, you can post questions at any time during the webinar on the question box located at the bottom of your screen under the main webinar window. We will try to answer the questions via chat during the session and also have a dedicated 15-minute Q&A session at the end of the webinar. If at any time during the webinar the audio or visual should stop or stutter, simply refresh your browser, which will reset your buffer and should get the webinar going up and running again. If you have any other problems, please consult the Having Problems section to the right or contact live support by clicking on the red button below the webinar window. That brings us to the end of the 60-second countdown to the webinar. I welcome you all again to today's Blockchain in Aviation and Logistics webinar presented by Air France Industries KLM Engineering and Maintenance, Microsoft and Ramco Systems. I'm Cynthia and I will be your host for this webinar. Blockchain is believed to be the next big technological disruption that would impact multiple industries including aviation and logistics. Blockchain can act as a digital ledger where every single action about each of the part, be it manufacturing or maintenance or disposal, gets recorded digitally and accurately. Imagine the power and the business impact of such a technology in aviation or logistics domain. Amongst us today, we have airlines, heli operators, OEMs, MROs, logistics service providers, and technology experts joining this session from around the globe. Our first speaker to address you all is Mr. James Conber, Director Innovation from Air France Industries KLM E&M. James will speak on the innovation initiatives of AFI KLM E&M through the work happening in the MRO lab, also covering the reasons and benefits of the current blockchain focus. Our second speaker is Mr. Richard, Cloud and Blockchain Evangelist from Microsoft. He will be giving an overview on blockchain and about Microsoft's contribution to Ethereum. He will also touch upon the blockchain applications across different industry verticals. Our last speaker is Mr. Ramesh, Head of the MRO Lab in Singapore. He will walk us through blockchain use cases in aviation and logistics and also show a live demonstration of the solution in action. Over to you, James.
Hello everybody, my name is James Conberg. I'm the Innovation Director for Air France KLM Engineering and Maintenance, and I'm very pleased to be with you on this webinar to share some of our experience on innovation and experimentations using blockchain. First, few words to present us. What is making us special is that we both operate and maintain aircraft for Air France and KLM fleet and also to third-party customers. And we have an extended capability list, including new generation aircraft such as the 787 and the A350. We are one of the leading MRO providing maintenance services to more than 200 customers worldwide. And we can almost provide anything you need to support your aircraft, your engines, your components, and your aerostructures. Adaptiveness is one of the values recognized by customers. We have a global and international presence in Paris, Amsterdam, US with Barfield, Dubai, and a growing presence in Asia. The objective is to be closer to our customer base. This is the list of all our customers worldwide. We've, as already mentioned, a strong development on new platforms. Nevertheless, competition is very high in our industry, which at the end is good for the airlines. And to differentiate our services and to remain competitive, we need to innovate. So to help us to innovate, we have created the MRO Lab, which is a program where all innovations developed by AFI KLM E&M converge. The MRO Lab uses different tools to help us innovate. Our participative innovation program from all our employees, our partnerships with universities, startups, industrial partners, and the MRO Lab Singapore, our co-innovation center with Ramco Systems. Our main objective is to use design thinking to prototype, experiment new solutions, tools, and services. One of our strong focus is of course digitalization, both for our customers and our employees. Examples of innovation developed by AFI KLM E&M are Prognos, our predictive maintenance solution using to detect component failures or engine failures, our virtual training tool for the 787, robotics to inspect engine parts and aircraft, complex engine parts repairs, and digital solution for employees in the cabin to identify parts or to modify the cabin layouts. Like other new technologies, experimentation has to be done, as we are convinced that we learn by doing. But we also keep the following principles. The use case has to be realistic and senses a precise business need. We do not push blockchain just for the technology's sake. It has to be tailor-made to the use case selected, and we need to select the right protocol. And third, we need to keep a multi-dimensional approach with legal, organizational, and change management issues. We think that the 4 key features of the blockchain, which is resilience, traceability, integrity, and disintermediation, are well suited to the aviation supply chain. And we have selected the following simple use case to test the blockchain technology with the removal of one unserviceable component from the operator aircraft and replaced by a serviceable component delivered by the MRO. This will later be presented by Ramesh, which is heading our co-innovation center in Singapore.
Thanks, James. Over to you, Richard.
Hello everyone. There you heard from James about how Air France KLM is using the innovations brought about by blockchain at the MRO Lab. My name is Richard Knight and I am part of Microsoft Asia, working on blockchain technologies across our public cloud platform, Azure. In this session, I want to ensure that we understand why there is so much buzz around this technology, but at the same time, give you an idea about what customers are doing in this space, including our work at Microsoft. Blockchain started back in 2008 with the introduction of Bitcoin, and since then we have seen various cryptocurrencies, virtual currencies, e-currencies and tokens making headlines, each with different levels of success. However, in the last couple of years, the renewed enthusiasm on the blockchain front focuses on the distributed ledger capabilities of this technology, opening it up to use cases beyond the tokenization of assets. Blockchain is a combined effort of tried and tested technologies over the years. If you look at any distributed ledger system, it's based on cryptography. Stock, standard public and private keys that ensure we create transactions that are impervious to fraud and establishes a shared platform of truth. The ledger is distributed amongst the nodes in the network, and hence there's no central authority or single source of truth. The nodes are distributed throughout the world, each contain the most updated ledger, and the updates to the ledger are determined by consensus amongst the participating nodes. The technology is ledger-based, which means that transactions date right back to the source or the origin, providing this immutability and traceability characteristic. And all of this allows for sharing amongst parties that don't trust each other. And so the true value of a blockchain-based system increases exponentially as the ledger is shared more and more amongst trustless parties. There are many types of blockchains or distributed ledger systems, but they all have some common fundamentals. In the world of blockchain, every node contains a copy of the ledger. These nodes are distributed across the world and achieve consensus in various ways, determined by the blockchain protocol itself. Consensus is used to ensure that every node has the most updated copy of the ledger. With the ledger itself, it all starts with the first block known as the Genesis block. Each block contains a number of transactions. When the block reaches a certain size or limit, the block is capped, which means that all the transactions in a block are hashed and confirmed using a complex puzzle solved by the nodes making up the blockchain network. Once the block is capped, the hash of all the transactions in the block then forms the first transaction of the next block. This process of filling the block with transaction continues until the next block is capped and the hash of the transactions it contains becomes the first transaction of the following block. And so the process continues. All of this means that the blockchain is a chain of blocks, each block with transactions that are linked to the following block. Transactions being encrypted and hashed, making it extremely difficult to hack into. And so this blockchain or distributed ledger technology provides the underlying secure platform for trustless parties working on shared business processes. So if you look at any blockchain-based use case, it essentially can be broken up into three layers, and it all starts at the application layer. Your blockchain-based application or use case will determine the blockchain technology to be used. Don't try fitting your use case into the choice of blockchain that you've settled upon. For example, use cases around cryptocurrency have followed the path of Bitcoin. Use cases around cross-border payments tend to leverage Ripple as a blockchain layer, while use cases requiring some sort of programmable logic have moved towards Ethereum. There are also different types of blockchains. Blockchains where the transactions are available in the public domain is a public blockchain. Those shared within an organization form a private blockchain. Or you could also have member parties only sharing data, which makes up a consortium or semi-trusted blockchain. And last but not least, the nodes making up the blockchain network need infrastructure, whether these are virtual, physical, or cloud-based machines, in order to provide the relevant capacity and computation to maintain the ledger. And so we at Microsoft, we initially started out by using our public cloud platform Azure to provide the basic networking, storage, and compute for the nodes making up the different blockchain stacks. Over the last couple of years at Microsoft, we have created a number of different offerings available in the Azure Marketplace, allowing you to deploy different blockchain protocols in a single click, taking away the setup and install complexity and helping you get started quickly. We evolved this over time, adding scalability of the infrastructure, adding customization of deployment templates, and much more, so that you could select any image or install script, allowing your choice of blockchain protocol to be deployed on Azure. Over the time, we've learned that this is great for customers wanting to get started on pilots and POCs, but customers seriously considering this technology were missing some enterprise-grade functionality. And so we created Bletchley, Microsoft's architectural approach to building an enterprise consortium blockchain ecosystem. Now, to be clear, this is not a new blockchain stack. This is Microsoft's approach to bringing distributed ledger platforms into the enterprise to build real solutions for real business problems while keeping the platform open. For example, we talked earlier about blockchain being based on cryptography, and hence we must deal with public and private keys. Issues around key management, key rotation, key policies, key generation, all of this can be handled through existing Azure services like Key Vault Management. We know blockchain is all about transactions, and once we have transaction data, we want to have all sorts of analytics on it. Microsoft already has a rich set of data services in Azure, ranging from analytics to machine learning to artificial intelligence. Use cases involving IoT or Internet of Things, where tokenization of assets on the blockchain, we have assets being recorded using sensors and smart meters, is another example of integration that goes beyond blockchain technology. all of these additional services are existing Azure services. And so we've taken these services and plugged them into the Bletchley framework to provide enterprises with the features they need when developing blockchain use cases for their business problems. At Microsoft, we have also been developing our own middleware layer known as Cryptlet Fabric as part of the Bletchley architecture. If we think about blockchains as the data layer deployed in a three-tiered application, only a subset of features of a smart contract should be implemented on the blockchain. Complex business logic should be removed from the execution path, which allows the data layer to be optimized to reflect the distributed nature of the network. To pull the logic up above the blockchain into a separate middle layer, the logic code needs to have access to a variety of services, including secure execution, attestation, identity, cryptography, data formatting, and much more. It is this middleware layer that we refer to as the Cryptlet Fabric. And lastly, as you might have recently heard, we announced the COCO framework that provides enterprises with the reliability, scalability, distributed governance, and enhanced confidentiality they need without sacrificing the security and immutability that they expect. And so leveraging the power of existing blockchain protocols, trusted execution environments such as Intel SGX or Windows Virtual Secure Mode, distributed systems and cryptography, the COCO framework enables enterprise-ready blockchain networks to deliver throughput and latency at database speed. COCO is open and compatible with any blockchain protocol. Microsoft has already begun working with integrating Ethereum into the COCO framework, and we're also thrilled to announce that JP Morgan Chase, Intel, and R3 have committed to integrating their enterprise ledgers, Quorum, Hyperledger Sawtooth, and Corda respectively, into the COCO framework. All of the blockchain artifacts we deploy leverage the Microsoft Azure Cloud Platform. The scale, elasticity, and availability of services in Azure is second to none when it comes to its global reach and presence. The compliance and certification portfolio of the Azure Cloud provides you with the most relevant industry-grade requirements and certifications for your business. The openness of the platform supports various operating systems, databases, and blockchain technologies. And lastly, the choice of deploying on-premises in a virtual or containerized environment or leveraging a hybrid scenario that makes use of on-premises and cloud depends on your business needs. And we at Microsoft provide you with these choices. Azure provides a secure, trusted platform that allows you as customers to deploy any blockchain use case of your choice and integrate it into the world of analytics, IoT, machine learning, artificial intelligence, and much more. We have seen customers work on all kinds of use cases in the blockchain space. In the financial services space, we have use cases around cross-border payments, mobile wallets, trade finance, remittances, and KYC, or Know Your Customer. In retail and manufacturing, most use cases are about track and trace, identifying the origin or provenance of assets and tracking across supply chain systems. In the case of healthcare, electronic medical records shared with insurance organizations is quite popular. And in the case of government, land registry systems, utility systems, water systems, and digital identities are some of the talking points. We at Microsoft have had a number of customers, including ourselves, leverage our public cloud platform Azure to deploy and develop a number of these use cases. And so I wanted to highlight a couple of these customers before we wrap up. Webjet in Australia, these guys are an online aggregate hotel and flight booking company, very similar to a Booking.com or an Agoda. And so Webjet were having a number of issues around reconciliation of hotel bookings made through their portal. And this is something that I learned, which I did not know existed even in the hotel industry, is that there are a number of intermediate parties or players in the hotel line, which means that changes made to customer bookings don't always propagate to true, causing discrepancies. And so Webjet implemented a blockchain-based system using the Quorum blockchain technology from JP Morgan, and they have created a system to have visibility of end-to-end hotel bookings so that they don't lose money every time you as a customer cancel your trip. My next example is BHP Bulletin, one of the world's largest mining company, using blockchain to track wellbore rock. Wellbore rock is this rich mineral that's unearthed from the ground. It goes through different processes like cleaning, polishing, testing, all of which is carried out by geophysicists before it's stored away in government facilities in Australia. On many occasions, the lack of visibility of this rock causes delays in getting it processed due to scheduling, mismatched expectations, resourcing, and much more. BHP have created a blockchain-based system in their production environment based on Ethereum. And so now they have clear visibility of this rock as they trace and track it through different stages. All of this allows for testing agencies, lab agencies, geophysicists, all of whom are trustless contractors, to now work on a shared business process or system. And there are many more examples. Bank of America, Merrill Lynch, and Microsoft Treasury performing blockchain-based use cases in the field of trade finance. Amy in Taiwan working on blockchain use cases in the field of IoT. PrimeChain in India working on blockchain in terms of consortium when it comes to banking. Have a look at microsoft.com/Azure in order to learn about what these different customers or partners are doing when it comes to blockchain. Also have a look about how you can get started leveraging the Microsoft Azure Cloud Platform to deploy your choice of blockchain protocol and then develop beyond that. Hopefully this session gave you some good insights about what customers are doing in this space, including the work we are doing at Microsoft. Feel free to reach out to me if there's any further questions, and look forward to you getting started with blockchain on the Microsoft Azure Cloud Platform.
Thanks, Richard. Over to you, Ramesh.
Thanks James and Richard for sharing, and especially setting the context of why blockchain and how it helps aviation and other industries. This is Ramesh and I head innovations at the MRO Lab Singapore. Let me start off with a brief introduction of Ramco and the MRO Lab Singapore before I share some details about the supply chain problem and the solution that we are going to demonstrate during this webinar. If I can pick one word that stands next to every Ramcoite, it's culture, and it fuels our innovation DNA. We call ourselves a 20-year-old startup with 1,600 plus entrepreneurs innovating at a crazy pace. All these disruptive innovations ultimately get included into our three product streams: ERP Logistics, Aviation, and HCM suite of products, which are currently being used by 200,000 plus users globally. The MRO Lab Singapore that we have set up in partnership with Air France Industries KLM Engineering and Maintenance, co-funded by Singapore government, is instrumental in trying out the adoption of these disruptive technologies to solve specific business challenges. Since its inception over a year back, it has tried out and or implemented lots of solutions like mixed reality based training, big data, IoT based smart toolbox, augmented reality based remote support, facial biometric using cognitive services, and of course blockchain solving supply chain challenges. The engagement framework we adopt in the lab brings method to the madness. The ideas generated in the lab go through a funneling process governed by the lab's innovation board, who would set priorities on these ideas based on indicators like cost-benefit analysis, current IT landscape, availability of skill sets, etc. All the solution accelerators set out to the market as pilots with the early adopter community before the big bang rollout. Having talked about who we are and what we do, let me now brief you on the problem that we are trying to address in two steps. What's the problem that we are addressing, and how blockchain is supporting us in addressing the problem. In aviation, a part goes through multiple stakeholders from cradle to grave. As you could see, it's quite complex. Parts move from OEM to operators to MROs to repair shops and so on and so forth. The key supply chain challenge is in making the right part and getting that part at the right time to the right place, with the right cost, with right reliability, safety and quality. Despite the process complexity in tracking and tracing the movement of parts, it's very essential to track them across the supply chain for us to have traceability across the ecosystem, to increase the efficiency of maintenance, to comply with the regulatory needs, to be able to retain the commercial value for resale or for leasing, to prevent frauds and counterfeits. Historically, real parts traceability is done poorly and is very expensive. Most of them are tracked by serial number within part number, and it hasn't worked very well. with multiple stakeholders, each one of them having their own standards and naming formats for the parts. Whose part number are we talking about? Not just that, continuous changes in the part data leave us with questions like where is the part coming from and when? Who brought it and where is it going? And what condition is it in? Tracking and tracing the no fault found or the blacklisted parts is one another major challenge being faced by the industry. Many a times, it's not just the requirement that decides the part to buy, but also the trade laws and political climate. A part may be available with a supplier, but cannot be obtained or information is not available because of export-import rules, embargoes, or trade blockades. Heterogeneous supply chain systems in every organization, sometimes even manual records keeping using physical documents, meaning the data is not readily available for analysis, and even if it's available, there is no trusted mechanism to share and validate the data. No way to track and trace the entire cycle in a transparent way. No obligation for any party involved to correctly furnish all information other than the last performed maintenance details. Having seen what type of challenges, let's discuss on how we are solving these challenges. We are addressing these supply chain challenges with the help of blockchain across original equipment manufacturers, operators, and MRO organizations. A governance council is set up which defines a set of transactions that each of these stakeholders could perform. This council would also be responsible for defining the validation or the mining process that audits and tracks every transaction performed by each of the stakeholders as stored in the blockchain, which gets replicated across the entire ecosystem after being validated. Typically, this solution will reside underneath the existing ERP system that you may be using with few additional screens that need to get and display the transaction history from this consortium-based blockchain. With lots of different stakeholders collaborating, the transactions are very dynamic, where anyone can potentially participate and look out for the entire part history for its originality and the condition. These stakeholders not only get to view the history of the parts movement, but also be able to verify and validate the true value of the parts, as they have a complete transparency across supply chains, which effectively means the prices we pay are an accurate reflection of the actual cost of the usage. No one organization can be trusted to broker the movement of all the parts, and that relying on one party or even a small collection of cooperating parties creates an inherent bias and weakness in the system. Blockchain with its distributed ledger therefore gives a neutral territory for sharing information across organizational boundaries. We have used Ethereum-based blockchain as a service to develop the solution that I am going to demonstrate. This is a framework that helps developers to create private, public, and consortium-based blockchain environments using Azure and Truffle as a platform to develop, test, and deploy the blockchains. While the actual solution involves deploying blockchain nodes for every stakeholder, but for this demo, we are going to show you from a single node. Let me now demonstrate one of the scenarios from our blockchain solution where the part movement is tracked between an operator and an MRO. In our demo, we are going to show you a scenario of Air France as an airline operator placing an order for an actuator to AFI KLM A&M as an MRO to recover from the AOG situation, and how AFI KLM A&M lends the part to Air France with utmost transparency being provided by the blockchain to the entire supply chain ecosystem. An Air France aircraft is in AOG situation due to hydraulic system failure. Troubleshooting carried out and figured that an actuator is required for fixing. An engineer from Air France is logging into the ERP system and requesting for the part. After realizing neither the actuator nor its alternates are available in stock, he has to raise a material request for the logistics team to either procure or loan from the external network as early as possible. He's going to now raise the part request against the work order. Once the part request is placed successfully, the transaction summary would be displayed as you see here. The part request is now received by the AOG desk They figured that the earliest sourcing of part is through loan from an MRO who could ship by the next available flight and requests a loan officer to place a loan request. Loan officer selects the material request that was flagged to be loan. After selecting the supplier, he enters all the details and then raises the request for loan order. On successful processing of his loan order request, this transaction is registered as a block in the blockchain and made visible to all the stakeholders of this blockchain. Rental administrator then receives the loan request. She logs into her ERP system to release the rental order. After she enters the part number, all serial numbers for this part number that are available for rental are displayed. She'd also be provided an option to view the complete transaction history of the chosen serial number. In this part serial history, she would be able to view the complete usage history across the ecosystem, which in turn would help her to define the right rental price for the part. Once the request for rental order is made successfully, the transaction is again registered in the blockchain as a block and the hashing details are displayed. The shipment details of the part shipped to the operator are then communicated to the operator's AOG desk through blockchain process. The receiving clerk then logs into the ERP system to process the receipt. After logging in, the receiving clerk provides the loan order details to complete the goods receipt process. Receiving clerk would also be able to view the authenticity of the part by viewing the entire history of this part movement. After the goods receipt process, the summary of the goods receipt is highlighted with the blockchain hashing details of this transaction. Engineer is then advised immediately for recovering the aircraft under AOG by the AOG desk. Engineer logs into the ERP system to process the attachment against the work order. Engineer chooses the work order and provides the received part details that needs to be attached to the aircraft. He then completes the component attachment and restores the aircraft to normal condition. He would then be able to view the summary of the work execution details. Aircraft flies with the loaned unit till the time it receives the original part. When the original is received in stock, the material planner shall inform the maintenance planner to make sure that the loaned unit is replaced with the original unit to avoid further loan charges. After receipt of the work order, engineer will remove the loan unit in serviceable condition and prepare it for return. Upon completion of the component removal, the summary details are highlighted, and this transaction is again registered as a block in the blockchain. Now that he has detached the part, it has to be returned to the warehouse, from where it has to be sent back to the MRO. Return part summary with the blockchain hash details are then displayed to the engineer to ensure the authenticity of this transaction. MRO's receiving clerk will then be intimated about the part return. He then logs into his ERP to receive the part. Receiving clerk, after logging in, enters the rental order number to check whether the part is in serviceable condition. He then validates the part usage by viewing the transaction history, from where he would be able to check if there has been any mishandling of the part, is the hashing of the block intact, and whether the part has been misappropriated before its return. Once he feels assured of the usage legitimacy, he will then accept the part's receipt. System displays the receipt summary indicating the completion of the receipt and also marks the transaction to the component history for traceability. This transaction is again registered in the blockchain as a block and the hashing details are displayed. Having seen on how blockchain helps in addressing the aviation supply chain problem, let me now share with you a few other blockchain use cases brewing at Ramco's innovation headquarters. Time and again, the food and beverage industry draws a lot of flack for adulteration of consumables, usage of toxic, unapproved ingredients, for holding items in storage longer than the stipulated safe period, and so on. All this resulting in losses to the tune of millions of dollars. Not just that, epidemics from the consumption of a certain batch of certain brands' contaminated products, in addition to international media announcing that such and such a company has pulled a particular batch of its products off the shelves and destroyed it. Besides the affected brand, other manufacturers are also negatively impacted with suspicion on the genuineness of these quality producers. In this situation, with the public recently having become particularly very health conscious, one of the most feasible and efficient solutions to this problem remains giving the customer a complete visibility into the movements of the consumables right from the raw material stage down to the last mile delivery. Logistics service providers purchase high-value precision equipment for their fleet, warehouse and other operations. Malfunctioning of such high-stake assets, especially vehicle parts, might result in very large-scale losses, which is why ensuring the authenticity of the equipment purchased is of supreme importance to LSPs. Most of the equipment manufacturers are certified by regulatory bodies, their products carrying stamps of authenticity given by the respective authorities. In many cases, such equipment may be replaced with counterfeit items by mercenaries. This is where the blockchain solution come in handy for LSPs, providing them with a fail-proof and tamper-proof solution to the problem of equipment forgery.
Thanks, Ramesh. That, in a nutshell, summarizes the MRO Lab initiatives and the innovations on board from a blockchain perspective. Now I'm going to open up the webinar for a 15-minute Q&A session. We will be answering those questions that came in during the webinar alongside those that you are typing in now. I'll read out the first question. How do you think the challenges of blockchain around regulatory constraints will be handled? Again, I'll repeat it. How do you think the challenges of blockchain around regulatory constraints will be handled? Richard, you may want to answer this.
Sure, and that's a great question. And I think with any new technology, it's important to have the regulators on board. I don't think we want to keep them at a distance, but now in the new world that we live in, we want the regulators to play an active role. In the engagements where I've seen success is having regulators participate either in a read-only capacity or in some audit capacity, because what it also allows you to do is for the regulators to think about how they can evolve the practices that they are developing. So don't keep the regulators at a distance, get them involved, get them to see what this new technology looks like, and bring them on board so as to also evolve their existing businesses.
Thank you, Richard. The next question is, what are the blockchain APIs for aviation industry? Are there any open aviation industry standards for the same? I'll repeat that for you. What are the blockchain APIs for aviation industry? Are there any open aviation industry standards for the same? Ramesh, do you want to take this?
Yeah, sure, Cynthia. Thanks. The first thing on the blockchain APIs for aviation industry, as of now, if you see, as said during the webinar, the blockchain application is going to reside behind any of your existing ERPs. The ERPs are going to perform their normal operations using their own functions, and it's going to be exposed as APIs to our blockchain to interface and collect the data and push it to the blockchain. Unless you want some business logic also to be included as part of the blockchain, wherein we can segregate the business logic and the data and the same can be performed, and the same business logic can be exposed as microservices, which can be made available for the entire consortium or for new members to start making use of it. And the second question regarding whether any industry standard, answer is no, nothing available at the moment. But as I said earlier, any of the existing ERP business logic can be exposed as API, and the same can be leveraged by the blockchain decentralized applications deployed across multiple nodes.
Thank you, Ramesh. I'll move on to the next question. Is it possible to implement blockchain in manufacturing or trading while still using regular currency instead of digital currency? Does that take away from the fundamental concepts of blockchain? I'll repeat that for you. Is it possible to implement blockchain in manufacturing or trading while still using regular currency instead of digital currency? Does that take away from the fundamental concept of blockchain? Richard, over to you.
Absolutely, you could do that. In fact, if you heard me talk, blockchain, while it started in 2008 and it was cryptocurrency focused, the latest success that we've seen in this space is actually around the distributed ledger aspects of this technology. So it's the ability of trustless parties to now work on shared business processes in a common understanding and a common manner. And so it's that aspect which you are bringing to the table. Your financial currency that exists today, whether it's in physical paper form or it's in a virtual form, would be used for back-end settlement, but you still would leverage the distributed ledger nature of this new technology in order to bring these multiple parties together and improve your existing processes and do things much faster for customers.
Thank you so much, Richard. The next question is for Ramesh. How does blockchain actually work for MRO labs?
Yeah, let me start off answering this, and maybe James could also answer after append to whatever I'm saying. See, what we do in the MRO labs is to solve business pain points. So as of now, the demo that you have seen is one problem, aviation supply chain problem that we are trying to solve. And we have taken that as a use case for evaluating the adoption of blockchain across the AFI KLM ENM ecosystem. And of course, this is going to interact with all the stakeholders in the entire aviation ecosystem in future. Apart from this use case, we're also evaluating a couple of more solutions, couple of more problems that could be solved using the blockchain across different functions, not from a supply chain perspective, but across a few other financial and a few other solutions that we are currently contemplating on, which I think we should pretty soon be able to test it out and roll it out to the market.
Yes, thanks, Ramesh. Just to complete on the blockchain initiatives that we have as part of the MRO Lab. So what we're doing is that we're doing brainstorming to select the right use cases, just to make sure we work on the right use case with a business value, business benefits. And then we decide if we do this use case with the MRO Lab Singapore, that's one solution, and we wish we one today. Or we have other options also as part of the MRO Lab in Paris or in Amsterdam. We have other scenarios that we're looking at using blockchain.
Thank you, James and Ramesh, for your inputs. I'll move on to the next question. Any examples of real solution in place in the supply chain? I'll repeat that for you. Any examples of real solution in place in supply chain? James, do you want to take this?
No, the idea was to have more, maybe Microsoft, maybe Richard, have more examples of real solutions in place, because we're looking a lot about proof of concept, experimentation, but my question was, more on real solutions in place in the everyday life. If you have examples, Richard, if you think about any industry using it already.
So given this technology is, come to light in the last couple of years, there are different customers at different stages, starting from POCs and pilots, to going beyond. Wellbore rock tracking with, is one of the examples I talked about earlier. that is essentially a process which is bringing a number of different logistical vendors into the same mix, and it's these entities which are today competitive of nature with one another. It allows them to work on a shared platform using blockchain. If you look at just general news about blockchain, supply chain is where we probably could have the biggest impact using this technology, given that it's so disparate and there's so many individual entities. Of course, because of the sheer size of it, the rate at which blockchain adoption is happening in the supply chain is obviously a bit slow. So I think overall we're seeing some good traction in this space, predominantly around track and trace of goods, track and trace of items, provenance of items, as they move from the source into the supply chain, into a distribution mechanism, to being available on stores and shelves at groceries, is a general theme where we are seeing blockchain use cases being used at different customers.
Thank you, Richard. Thank you, James. The next question is on how blockchain will be useful in IoT applications. I'll repeat that. The next question is on how blockchain will be useful in IoT applications. Richard, you may want to share your thoughts first, and then probably Ramesh and James can add on.
Sure. Blockchain and IoT is actually one of my favorites. If you look at the world of IoT today and take, for example, all of your smart meters and smart sensors, in a lot of countries, we have, the collection of solar energy. So we have these smart meters. They're collecting, they're monitoring the energy collected through solar panels on people's roofs. And typically, those smart meters would have the solar panel hooked into a battery system in the garage, or they would put electricity back into the grid. And so you would measure simple input and output. Now, the law of physics tells us that the longer the energy travels, the more it dissipates. So by the time the energy reaches the central grid, it's probably dissipated about 30–40%. But what if I now lived in a neighborhood where my neighbor probably needs energy and I'm generating excess of it? So here are use cases where customers are saying that, hey, I could take the solar energy, I could tokenize it. So now I have things like solar tokens. I put that onto a blockchain-based system, and I'm transacting with my neighbor, right? And so blockchain-based systems are used to transact. They're not just tokenizing the aspects, but they're looking at how much energy is exchanged, and they are serving as that source of truth and ledger, just like you would have in the case of your banking statement involving actual financial money.
Yeah, just to add to what Richard was talking about, even let me take the example of the aviation supply chain problem that I addressed. So the solution that we have created at the moment is tracking the digital asset at the moment. But now we are talking about tracking the physical asset as well. So combining the physical asset with the digital asset can be achieved through IoT. So we can have tags attached to all the physical assets and create associated digital assets, and the same can be tracked for movement between the entire ecosystem. So that way, I think it's definitely interconnected. IoT is the interconnection platform that can be leveraged on the blockchain to track physical and digital assets together in single framework.
Thanks, Ramesh. Thanks, Richard. James, do you want to add your input?
No. IoT is something we're looking at. Of course, later we will link that with blockchain. But first, it's through experimentation. We're doing side by side, and we learn by doing. And later, yes, we will combine both technologies.
Okay. Thank you, James. The next one is for Ramesh. Do you think blockchain can replace ERP? Or both can be integrated to get a more efficient way of handling?
Yeah, definitely, yes. It can work in side by side. The demo that we had shown, actually it resides beneath the ERP. So the blockchain decentralized applications will reside beneath the ERP systems. You can also replicate the functions of ERP in a blockchain, but that will make the blockchain heavy. So what we typically advise our customers and partners is to leverage your existing ERP functionalities to perform the functions as you do normally. And the blockchain is an additional element getting added to your ERP to provide visibility and immutable transactions the information that you want to share between different members in a consortium, you can share it from the ERP, put it in a blockchain, hash it, and the same can be viewed in a trusted manner. So definitely, it is going to go side by side. The blockchain applications will reside beneath the ERP application. It is not going to replace ERP completely.
Thank you, Ramesh. Thank you for the detailed answer. The next question is, what is the value addition of blockchain over existing logistics solution, and at what cost? Ramesh?
Yeah, so we are talking about a consortium of members. So the example that we talked about, the use case that we are currently working on the logistics side from our innovation headquarters in India, is that we are talking about multiple members from the manufacturer to the distributor to the retailer to the consumer. So we are talking about different people, different stakeholders using different logistics solutions or the ERPs or their legacy systems. And now we are talking about leveraging the blockchain to integrate all these disparate systems and provide visibility of the necessary information that needs to be made visible across this ecosystem. So yes, definitely it is going to add value to the existing logistics ecosystem. The cost-wise, it depends on what kind of visibility that we are intending to provide. If we are talking about creating one dairy farm, a dairy company in New Zealand created visibility on their milk packets, from which set of cows this milk was extracted. So that's the kind of visibility that is being provided on the logistics side, particularly on the retail side. So it depends on the kind of complexity, kind of use case, the problem that we are trying to solve. The cost depends on that.
Thank you, Ramesh. This question is for Richard. Who is allowed to enter transactions onto the ledger versus who can view them?
Sure, that's a good question, and this kind of goes back to the blockchain technology itself. If you see the presentation that we discussed earlier, blockchain is essentially a chain of blocks, very much like a linked list, and each of these blocks has got a series of transactions. And to confirm these transactions, this is where we start to introduce these minor nodes, where they solve this complex puzzle, they close this block, they confirm the block before they move on to the next block. And so it is the minor nodes that are confirming these transactions. If I look at who gets to be a minor node, it's basically anyone who wants to have write capabilities in a system. So if you take it back to a use case level, as Ramesh said, we have a distribution, we have a supply chain system, we have consumers. Consumers probably are not the ones who are going to have write mechanisms. They're probably going to have only read mechanisms. And so in that case, you would have the distributors and the suppliers having write facilities through mining nodes, whereas the consumers would probably have read facilities through what is known as transactional nodes. Governing this mining and transactional nature of the business can be set up through the means of a consortium body. So this is a framework that you can have in place to dictate rules of engagement or rules of governance between these different nodes. And that's essentially how you can have a situation where someone has read privileges versus read and write privileges in the case of a blockchain-based system.
Thank you, Richard. Thank you for the detailed answer. The next one is, how does blockchain handle manual data or non-electronic data? James, maybe you want to start off first, and then Richard can add his inputs.
Yes, it's true that in the aviation industry, we still have not all our data digitalized. We still have handwriting data. And the first step, and that's what we're doing at the moment, is to go to a fully digital solutions on all the supply chain and all the aviation data that we get. So that's the first step. And of course, before we do that, blockchain cannot be applied on non-electronic data. So that it's not possible.
Thanks, James. Richard, do you want to add?
Yeah, so very important, reconciliation of data as you move through the system, and so that should be in an electronic format. Otherwise, you're going to have discrepancies. You might have data on the blockchain which is accurate and true, but that does not reflect the actual state of the data, which is not resident on the blockchain. A good example could be in the shipping industry. A lot of contracts that get exchanged are all paper-based systems. And here we have an industry which is trying to move into a blockchain platform. But the first step that needs to happen in that industry before it becomes blockchain-based is actually the digitization of data, especially the contracts that have existed for several years. So definitely agree with James. Digitizing of data is one. And then once we've digitized that data, and to some of the questions asked earlier, that's where that data would start moving into various ERP and CRM systems. And then some of that would then flow into a blockchain-based system, only what is required to share between parties that don't trust each other when you're trying to solve an overall business problem amongst these trustless party entities.
Thank you, James and Richard. How does one ensure the information relayed across the blockchain is accurate? Richard, you may want to answer this.
Yeah, so again, this kind of goes back to what I was talking earlier. In the world of blockchain, it's a peer-to-peer system at the end of the day, right? And so the different peers, or the nodes, as we call it in the blockchain-based system, they need to come to a majority, or as we call it, consensus. Different blockchain protocols have different consensus algorithms that they achieve. You might have heard things like proof of work, proof of stake, proof of authority, and there's many others being developed. And so at the end of the day, there needs to be consensus amongst the majority of nodes in the network to validate the information in the ledger. And it's that validated information or updated copy of the ledger which serves as a source of truth. Just piggybacking off this, if you have multiple sources of this truth, what then happens is that you have a joint in your blockchain network where you have multiple parties actually having different blockchains or different updated copies of the ledger. And that's when you start to look at things like forking, as some of you might have heard in the blockchain world. And that essentially means I have disparate or different sources of truth, and that now requires me to call out two separate paths or forks.
Thank you, Richard. There's one more question for you. We tried to create apps using framework, but we heard that using Ethereum can only be used if public blockchain scenario. Is it possible to use for private blockchain?
Absolutely. So Ethereum is a fantastic protocol. It started off with public blockchains in mind. People love the programmable nature of Ethereum. They love the smart contract aspect of it. And so obviously they want to use it in the private or the consortium-based context. And you could definitely do that. In fact, I would highly encourage you to have a look at JP Morgan's blockchain stack called Quorum. That is actually a modified version of the public Ethereum blockchain that can now be used in a private context. So we see a lot of different vendors and customers doing this, looking to take public blockchain protocols and then modify consensus algorithms to then suit a private or a consortium-based context.
Thank you, Richard. Given the time, I think we'll take a couple of more questions and we'll close the session. The next one is for Ramesh. Why could the tracing path use case not be done with a cloud solution?
Yeah, thanks, Cynthia. Actually, if you look at it's a basic question on why do we need a blockchain for these kind of integration between disparate systems. See, the point is we are talking about a consortium of members using a disparate heterogeneous systems. One person may be using SAP, one person may be using Oracle, one person may be using some other ERP. And now what we are talking about is creating a connected system which takes the data from all the systems. Not just that, also to create some kind of encrypted information that cannot be changed. Immutable transaction is what we are planning to create. So that's the reason why the existing solutions cannot be implemented. Unless otherwise, we go in for a cloud solution that can be implemented across the entire consortium it's a different scenario. But we are talking about a scenario where people are having heterogeneous systems, and we are creating a networking of all the systems by transacting the relevant data or the useful data within this consortium. So that is possible only using blockchain.
Thank you, Ramesh. This will be the last question for the day, given the time. Is the blockchain hosted on Azure platform shared by stakeholders? I mean, only a single will remain in the cloud. In case of non-cloud, the same blockchain will be available in the stakeholders' on-prem infra. That's for you, Richard.
Yeah, this is a good question, right? And I think it's a good question because there's a lot of people thinking about cloud right now. There's a lot of people who have on-premise infrastructure and are looking to move to cloud. If you take a step back and look at blockchain, blockchain is this distributed ledger technology. So there's a ledger, right? And every node in the network maintains the updated copy of the ledger. And these nodes could exist in various factors. They could exist as virtual machines in a cloud. They could exist as virtual machines on-premise, or they could exist as physical machines. And even when I say machines, I use the word machine in the context of a server, but this could even be in the form of a containerized platform like Docker or Kubernetes. So yes, these nodes could exist anywhere. They could exist on-premise. They could exist on cloud. These nodes then have the relevant blockchain protocols installed on them, and they form this network in order to create this uniform, updated, distributed ledger. Now, the benefit, I would say, of using a public cloud platform like Azure is getting some of the scale, right? So given that Azure has got a global context, you could easily spin up these nodes. You don't have to worry about maintaining this infrastructure. You don't have to worry about capacity. You're running out of, into performance issues with the limited number of nodes you have. You can easily scale them out. And so the reason we encourage, customers, and, that's one thing when we started these discussions with Ramco, they were quite on board with using Azure, is because you could get started really quickly on the Microsoft Cloud Platform. And in the scenario where this was not working for you, when you were failing, you did not spend so much money in order to fail, right? So it's, fail fast, right? Learn from it, and then be able to set up things quickly the next time you want to do this. And so that's what we've seen across the board. Customers leveraging cloud for these new technologies in order to get started quickly, prototype things, make sure it works, and then once they've seen the success of it, then scaling it out through that cloud platform.
Thank you, Richard. That was pretty detailed. Okay, with this, I conclude the webinar. It was a very active Q&A session, and we still have a lot of questions flowing in. We will be answering all these questions through emails next week. So thank you so much to all of you for joining us. If you're interested to continue your discussions with us, please do follow our social media handles, and do feel free to write to us. This is Ramco signing off for now. Thank you.